Okay, hi everyone, welcome back to this video series on Comptia Security Plus packet filtering. Packet filtering inspects each packet passing through the firewall and accepts or rejects it based on rules. However, there are two types: stateless packet inspection and stateful packet inspection, also known as SPI or a stateful firewall. A stateless packet filter, also known as pure packet filtering, does not retain memory of packets that have passed through the firewall. Due to this, a stateless packet filter can be vulnerable to IP spoofing attacks, but a firewall running stateful packet inspection is normally not vulnerable to this because it keeps track of the state of network connections by examining the header in each packet. It can distinguish between legitimate and illegitimate packets. This function operates at the network layer of the OSI model. NAT filtering, also known as NAT endpoint filtering, filters traffic according to ports, TCP or UDP. This can be done in three ways: by way of basic endpoint connections, by matching incoming traffic to the corresponding outbound IP address connection, or by matching incoming traffic to the corresponding IP address and port. Application level gateway (ALG) applies security mechanisms to specific applications such as FTP or BitTorrent. It supports address and port translation and checks whether the type of application traffic filter is allowed. For example, your company might allow FTP traffic through the firewall but might decide to disable telnet traffic. The ALG checks each type of packet coming in and discards telnet packets. Although this adds a powerful layer of security, the price that it is resource intensive, which could lead to performance degradation. Circuit level gateway works at the session layer of the OSI model and applies security mechanisms when a TCP or UDP connection is established. It acts as a go-between for the transport and application layers in TCP IP. After the connection has been made, packets can flow between the hosts without further checking. Circuit level gateways hide information about the private network, but they do not filter individual packets. A firewall can be set up in different physical configurations. For example, in Chapter 6 Network Design Elements, we discussed implementing a DMZ. This can be done in a back-to-back configuration. Two firewalls surrounding the DMZ as shown in Figure A2, or as a three-leg perimeter configuration. Generally, there will be one firewall with the network and all devices and computers residing behind it. By the way, if a device is behind the firewall, it is also considered to be after the firewall, and if a device is in front of the firewall, it is known as being before the firewall. Think of the firewall as a drawbridge of a castle. When you are trying to gain admittance to the castle, the drawbridge will probably be closed. You would be in front of the drawbridge and the people inside the castle would be behind the drawbridge. This is a classic analogy, but should help you understand the whole in front of and behind business as it relates to data attempting to enter the network and devices that reside on your network. Logging is also important when it comes to a firewall. Firewall logs should be the first thing you check when an intrusion has been detected. You should know how to access logs and how to read them. For example, Figure A3 shows two screen captures. The first displays the internet sessions of a basic SOHO router firewall, and the second shows log events such as blocked packets. Look at the blocked Gunatella packet that is pointed out. I know it is a Gunatella packet because the inbound port of my firewall that the external computer is trying to connect shows as port 6346. This associates with Gunatella. Gunatella is an older peer-to-peer file sharing network. None of the computers on this particular network use or are in any way connected to a teleservice. These external computers are just random clients of the Catella P2P network trying to connect to anyone possible. It's good that these packets have been blocked, but maybe you don't want the IP address shown 24.253.3.20 to have any capability to connect to your network at will. To eliminate that IP, you could add it to an inbound filter to an ACL. So far we have discussed host-based firewalls and just how network-based firewalls. However, both of these firewalls can also fall into the category of application firewall if either type runs protocols that operate on the application layer of the OSI model. Then it can be classified as an application firewall. That means that it can control the traffic associated with specific applications. This is something a stateful network firewall cannot do, as this function operates at the application layer of the OSI model. Many host-based firewalls fall into this category, but when it comes to network-based firewalls, it varies. A basic SOHO router with built-in firewall capabilities will usually not fall into the application firewall category. However, more advanced network appliances from companies such as Barracuda, Citrix, Fortinet and Smoothwall do fall into this category. This means that they allow for more in-depth monitoring of the network by controlling the input, output and access to applications and the services all the way up through the application layer of the OSI model. These appliances might be referred to as network-based application layer firewalls. Now that's a mouthful. Just be ready for multiple terms used by companies and technicians. Going a step further, some of the aforementioned network appliances have tools that are designed to specifically protect HTTP sessions from XSS attacks and SQL injection. These types of tools are known as web application firewalls. WAFs can help to protect the servers in your environment. Firewalls are often considered to be all-in-one service, but actually they provide specific functionality as discussed in this section. Still, it is common to hear people refer to a firewall when they are really talking about another technology or even another device. For example, many SOHO users have all-in-one multifunction network device. This device has 4 ports for wired connections plus a wireless antenna. It connects to all computers to the internet and finally has a firewall built in. Because some users consider this to be simply a firewall, you should teach them about the benefits of disabling SSID broadcasting and enabling MAC filtering. By disabling the service set identifier SSID broadcasting, the average user cannot connect wirelessly to the device. An attacker knows how to bypass this, but it is an important element of security that you should implement after all trusted computers have been connected wirelessly. MAC filtering denies access to any computer that does not have one of the MAC addresses you list. To make matters a bit more interesting, a firewall can act as or in combination with a proxy server, which we discuss in the following section. Proxy servers. A proxy server acts as an intermediary for clients usually located on a LAN, and the servers they want to access usually located on the internet. By definition, proxy means go-between or mediator, acting such as a mediator between a private network and a public network. The proxy server evaluates requests from clients and if they meet certain criteria, forwards them to the appropriate server. There are several types of proxies, including a couple you should know for the exam. IP proxy secures a network by keeping machines behind it anonymous. It does this through the use of NAT. For example, a basic 4-port router can act as an IP proxy for the clients on the LAN it protects. An IP proxy can be the victim of many of the network attacks mentioned in Chapter 6, especially DOS attacks. Regardless of whether the IP proxy is an application or a computer, it should be updated regularly and its log files should be monitored periodically and audited according to organization policies. Caching proxy attempts to serve client requests without actually contacting the remote server, although there are FTP and SMTP proxies among others. The most common caching proxy is the HTTP proxy, also known as a web proxy, which caches web pages from servers on the internet for a set amount of time. Examples of caching proxies include Wingate for a Windows system and Squid, commonly used on Linux-based systems. An example of a caching proxy is illustrated in figure 8.4. For example, let's say a co-worker of yours, client A, accessed www.google.com and that she was the first person to do so on the network. This client request will go through the HTTP proxy and be redirected to Google's web server. As the data for Google's homepage comes in, the HTTP proxy will store or cache that information when another person on your network, client B, makes a subsequent request for www.google.com, but the bulk of the information will come from the HTTP proxy instead of from Google's web server. This is done to save bandwidth on the company's internet connection and to increase the speed at which clients' requests are carried out. Most HTTP proxies check websites to verify that nothing has changed since the last request. Because information changes quickly on the internet, a time limit of 24 hours is common for storing cache information before it is deleted. Web browsers make use of a proxy automation configuration pack file, which defines how the browser can automatically choose a proxy server. The file itself and the embedded JavaScript function pose a security risk in that the file can be exploited and modified, ultimately redirecting the user to unwanted and potentially malicious website. Consider disabling pack files and auto configuration in general within client web browsers. Other type of proxies are available to apply policies, block undesirable websites, audit employee usage, and scan for malware. One device or computer might do all these things, or just one or two. It depends on the software or the appliance installed. Reverse proxies can be implemented to protect a DMZ's server's identity or to provide authentication and other secure tasks. This is done when users on the internet are accessing server resources on your network. Generally, a proxy server has more than one network adapter so that it can connect to the various networks. It is acting as a mediator for each of the network adapters in a proxy. Should be periodically monitored for improper traffic and for possible network attacks and other vulnerabilities. A proxy server might be the same device as a firewall, or it could be separate. Because of this, a multitude of network configurations are possible. Proxy servers, especially HTTP proxies, can be used maliciously to record traffic sent through them. Because most of the traffic is sent in unencrypted form, this could be a security risk. A possible mitigation for this is to chain multiple proxies together in an attempt to confuse any onlookers and potential attackers. Most often, a proxy server is implemented as a forward proxy. This means that clients looking for websites or files via an FTP connection pass their requests through the proxy. However, there is also a reverse proxy where multiple HTTP or FTP servers use a proxy server and send out content to one or more clients. These HTTP and FTP servers could take could be located in a server farm or similar grouping, and the reverse proxy might also undertake the role of load balancer. In this situation, a reverse proxy can act as another layer of defense for an organization's FTP or HTTP servers. An application proxy might be used as a reverse proxy. For example, Microsoft's web application proxy, which enables remote users to connect to the organization's internal network to access multiple servers. These are often multi-purpose by design, allowing for HTTP, FTP, email, and other types of data connections. However, it could be that you have a single application stored on several servers. Those servers can work together utilizing clustering technology. The clustering might be controlled by the servers themselves, or more commonly, a load balancer can be installed in front of the servers that distributes the network load among them. That load balancer in effect acts as a reverse proxy. Regardless of the type of proxy used, it will often modify the requests of the client computer, whatever that client is, providing for a level of anonymity. But in some cases, you might need a proxy that does not modify requests. This is known as a transparent proxy, which allows for increased efficiency. There is less protection for the client system. Another example of a proxy in action is internet content filtering. An internet content filter, or simply content filter, is usually applied as a software at the application layer and can filter other various types of internet activities such as websites, accessed email, instant messaging, and more. It often functions as a content inspection device and disallows access to inappropriate web material, estimated to a big percentage of the internet or websites that take up far too much of an organization's internet bandwidth. Internet content filters can be installed on individual clients, but by far the more efficient implementation is an individual proxy that acts as a mediator between all the clients and the internet. These proxy versions of content filters secure the network in two ways: one, by forbidding access to potentially malicious websites, and two, by blocking access to objection material that employees might feel is offensive. It can also act as a URL filter. Even if employees inadvertently type an incorrect URL, they can rest assured that any objection material will not show up on their display. Internet filtering appliances analyze just about all data that comes through them, including internet content, URL, HTML logs, metadata, and security certificates, such as the kind you would automatically receive when going to a secure site that starts with HTTPS. However, revoked certificates and certificate revocation lists, or CRLs, will not be filtered because they are only published periodically. Some of these appliances are even capable of malware inspection. Another similar appliance is the Web Security Gateway. Web Security Gateway, such as ForcePoint, previously known as WebSense, acts as a go-between devices that scan for viruses, filter content, and act as data loss prevention DLP devices. This type of content inspection, content filtering, is accomplished by actively monitoring the user's data streams in search of malicious code, bad behavior, or confidential data that should not be leaked outside the network. As you can see, many options for security devices are available for your network, and many vendors offer them. Based on price, you can purchase all kinds of devices, from ones that do an individual task to ones that are combinations of everything we spoke about so far, which are also known as all-in-one security appliances, or Unified Threat Management UTP devices, discussed in the upcoming NIDS versus NIPS section. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing, and subscribing. Thank you.